Background. My name is Malcolm Snook. My history is in the advertising industry. I used to run an advertising agency in the southeast that handled Yamaha, the government of New Hampshire for tourism, Arbus locks from Germany, Nippon Denso spark plugs, some quite big brands. I kind of burned out, I suppose you'd say. I retired at 47 and bought a yacht and ran away for what turned out to be more or less 14 years. 10 years on my own boat and then some delivery jobs on other people's boats. And then I ended up settling in Sheffield. That's another story. And after a little while I thought I ought to do something. And I hadn't worked for anyone else for 35 years or so. So I thought I'll contact one of my old clients and see if he'd give me a reference if I start applying for jobs. So I rang up this old client who had been involved in motorcycle security and asked him, I'm thinking of going out and doing something hopefully useful and I'd get a job, and would you give me a reference? And he said, I've got something you could help me with. So at the time when I was closing my business and running away to sea, he bought an electronics company which made zero-drain motorcycle immobilizers. That market shrunk as motorcycle manufacturers put their own security on. And he became involved with Armstrong World Industries. This is probably an Armstrong World Industries ceiling, is it?
Yes.
Okay. Well, if you look at this and then look above your head, you'll see some panels which are well nigh identical. So we're licensed by Armstrong World Industries to make their sound panels. And unashamedly, really, I sort of started coming to these things partly because I was interested and partly to network with the great and good of Sheffield, that's you. So I then started obviously learning more about smart cities, and Chris and I have both been doing the Future Learn course. I don't know if anyone else, it was mentioned at the last meeting, I don't know if anyone else is doing the Future Learn course. But I've started to learn what smart cities are all about, and it seems to me that it's about making things better, whether it's air quality or whether it's about traffic flows or whether it's about health. It's about making things better. And in our own small way, we have a product that makes certain things better. And there are several sectors that I'm interested in. One is education. I think education is very important because all of these people, the presentations that came before me were a little more highbrow, and it all begins with education. You can't do anything without educated people. So that's an important sector. But so is retail, so are transport hubs, communication. And so I posed the question, because I know there's people here from the uni and Sheffield Home, did you ever struggle to hear the teacher at school? Or did you ever struggle to follow every lecture that you went to at your university? We kind of have a solution for that. Have you been that teacher or lecturer struggling to make yourself heard? I gave this presentation recently to a teacher, and I said, we can't make teachers more interesting, but we can make it easier for them to be heard. And she said, actually you can make teachers more interesting, because when I'm bawling at the top of my powers to be heard by the kids playing around at the back, I can't put any colour or expression into my speech, and so the lesson actually does become less interesting. If you've been that person making a presentation, especially in a big place, and you see people halfway down the hall and towards the back rustling papers and talking amongst themselves because they can't hear you properly, then that's very off-putting for you as a presenter. Transport hubs. How often have you been at a station, a shopping centre, at an exhibition, an airport, and you've heard an announcement, there was an announcement, but you really couldn't decipher it well enough to know whether it was your departure gate, your flight, or you went to the wrong platform because you didn't hear the number correctly. So what the business that I'm in is largely about communicating clearly. But there are also issues of privacy and distraction. So if you've got an open plan office, if you've got a call centre and somebody's making a call here, and there's somebody there making a call, and there's somebody there and there and there and there, it's a distraction. So sound masking is a very important contribution to solving that problem. In fact, I'll give you an example. So this is our bread and butter, eye ceilings. We put sound panels in the ceiling. You can see in this ceiling that cone speakers have been cut in, and you'll see that there are quite a lot of those cone speakers cut around, cut into the ceiling all over. That would create a sound field, but a cone speaker sends sound out like this. That's why you need quite a few of them to get the overlap. A sound panel sends sound out like this. So for every 3 or 4 cone speakers you might cut into a ceiling, one sound panel will create a much broader field of clarity and so on and so forth. It's a British product. It's made in the north of England. It's not made in Sheffield, but it is made in the north of England. I just happen to live in Sheffield now. We have done a lot of development work with Salford University. I don't believe Hallam has an anechoic chamber. I don't know if University does, but we are working with Salford University so that we can quantify how the sound spreads and so on and so forth, and the frequencies and what have you. So flat sound panel technology allows audio speakers to be placed discreetly or completely invisible in any suspended ceiling, or hung in a designer case to complement other ceiling designs. So if you don't have a suspended ceiling, we have a completely enclosed one. But we are doing a lot of prototyping work at the moment. At the heart, something like this is the smallest, cheapest version, a single exciter. This is a piece of Corex, the sort of stuff that you make exhibition signage out of. Stick that on there. A few more electronics, obviously, maybe a transformer as it's needed and so on. But this will excite the Corex, and the Corex will now become a speaker. So the sound comes out on this side largely. So sound masking, for example, I give you just one example of a prototype that we're working on at the moment. This is a true story. So big company, they've got air conditioning ducts in the ceiling and going through the building. Lady goes into the stationery cupboard and she hears a meeting going on somewhere else in the building because the sound has been transmitted through the air ducting. And she hears that her close friend and colleague is being manoeuvred out of the company. You know, whether she's going to be made redundant or whether they've got enough on her to get her sacked or whatever, but she's listening to this, so she immediately rushes off and tells her friend, who comes to the stationery cupboard and listens in. Now there's a big legal case. Sound masking is a way of broadcasting white noise, sound waves which are frequencies that are common in speech, and depending how you set it, you can make it such that people within a certain area can only make out one word in 5 or 8 or 10. So they know there's a conversation going on, but it's kind of unintelligible. You can't follow it. So this company that's been sued, big company, big offices, lots of ducting, has asked one of our partners, sound masking specialists, to put sound masking in the ducting. Well, that's a nightmare because the ducting was all going through the building, so you've got to get the ducting out, put the speakers, plenum speakers that they've been using in the past, in the ducting and put it all back together. Well, we can just whack something on the outside of the ducting that creates the sound waves inside the ducting. So that's a considerable advantage, obviously. Another prototype that I have here, this is actually a light. It's an LED light panel. So one of our partners is one of the biggest installers of lighting systems in department stores and shopping centres. And a lot of these places, I mean, traditionally lights have been bulbs. Bulbs use a lot of electricity. Aside from the environmental aspect, the electricity bill is huge. So shops and department stores, shopping centres, if they go over to LEDs, then they save a lot. Well, an LED panel is flat, and we can make almost any flat surface into a speaker. So this one panel is both an audio speaker with a good spread of sound, and it's a light. So you simply take that panel out, drop that in, and you've got light and sound in one fell swoop. So the panel itself, it's a prototype, I don't know what it's going to cost yet, but in terms of installation, it's a big saving. So linked to an amplifier, or we can do panels which have an amplifier built in and you can slave off of them. These things have a multitude of uses. Voice reinforcement in large lecture halls and classrooms means you don't get the disruption of the kids at the back as they can't hear, and it's shown to improve learning outcomes. Discreetly spread around in strategic positions, it means that everybody can hear clearly and nobody gets deafened. If you have speakers at the front of the auditorium, people at the front get deafened, people in the middle are okay, people at the back are struggling. A few of these in the ceiling, job done. As I said, they can be used for broadcasting the white noise to aid privacy. There's other kinds of sound masking. They might have birds tweeting in a motorway services to make it feel more relaxed, you know, but it's obviously not real birds. So it's ideal for schools and universities, offices and call centres, retail outlets and showrooms, council chambers. There is one council chamber in England that's already got it, I can't remember off the top of my head, transport hubs and exhibitions. So it's not smart city technology at the moment, although what the future holds, I don't know, but it is the built environment, as Matt was talking about, and it is about making things better. It can aid educational outcomes by putting it in LED light panels and so on. It can make things cheaper and easier to install. It's pretty nuts and bolts compared with the stuff that you've been hearing about at these presentations. But, and of course it can be used for just common or garden entertainment. But largely it's about making things better. So if you're involved in refurbishment, we've sold some panels to Edinburgh University for their new medical school, but they're going to be months getting the asbestos out of the old building, so I'm not quite sure when that's going to be up and running. But whether you're a client, an architect, a specifier, an installer or whatever, we want to talk to you because we can produce this discreet, attractive, effective sound system, whether it's for sound masking or anything else. This is actually a room at a well-known football club not a million miles away from here. Because I believe in education, I do quite a lot of invigilating for both of the universities. That hall is used for exams, and this circular speaker has been cut into a mineral fibre tile. Metal ceilings are more expensive. A lot of people go for mineral fibre because it's cheap, but it's very friable. The vibration from that speaker has cracked that tile. Now it's an accident waiting to happen. You know, it could drop out of the ceiling. And even if it doesn't drop out of the ceiling, it's ugly. So, you know, if you want a neater solution, that's me, and that's it, as quickly as I can. Thank you.
Thank you very much.
Any questions? You're welcome. I have one question.
Yeah.
And that is, obviously, the technology is all around ceiling tiles, but essentially you're connecting amplifiers and speakers to objects that can vibrate.
Yeah.
So, are you doing anything with other surfaces?
Yeah, we have a
outdoor
whole
hoardings
range.
or you know, things externally in the built environment where audio.
Yeah, we have a whole range of prototypes going on at the moment. There's a company in Bolton called Video Poster. And they put a printed poster in a shop window with a video screen built in, but no sound. And we had already prototyped glass whiteboards and mirrors, in fact, for hotels. So that, you know, the hotel needs to make an announcement. Maybe, I mean, coming back to the fire thing, I was in a hotel once. It was, I don't know, middle of the night, 2 o'clock in the morning or something. I was fast asleep and the phone started ringing. And, you know, you kind of come around, and you think, oh God, who's phoning me at 2 o'clock in the morning? You reach for the phone, it stops ringing. So I'm now awake, so I go to the loo and I'm having a wee, and the phone starts ringing again. So you sort of force yourself to try and stop, and you answer the phone, not in the best frame of mind. You say, yes, and somebody says, can you please evacuate? The hotel's on fire. And you say, what kind of a wind-up is this? Why hasn't the fire alarm gone off? And they say, well, it's only your wing of the hotel that's on fire. So we thought we'd ring everybody and just evacuate the rooms in that wing. Oh, all right, go and finish my wee. Open the door and the corridor's full of smoke. So then I believed it. But we can put these things behind the mirrors or the pictures in a hotel room, and then they've got a way of speaking to you or making a sound in an emergency, all sorts of things. We have a flight case for Formula One mechanics, but it could just as well be Kylie Minogue's wardrobe when she's on tour, big flight cases. And in there is a miniature amplifier, a Bluetooth receiver, and the whole thing becomes a speaker. So the first guys that turn up at the race meeting have to set the pits up. And you know, they like to have music while they work. So a lot of them are putting their iPhones or whatever in a docking station, and it's very nickable. But their tool case or their data logging case, they can keep their iPhone in their pocket and the case plays music. It's waterproof, it's robust. So we can make glass talk, we can make wood talk, we can make pictures talk. The sound masking people are doing a listed building, and they have to get planning permission for every single hole that they drill in this historic building. But they've been asked to put acoustic panels on the wall, and we are currently prototyping acoustic panels so that they can also be used for sound masking in the historic building. So yeah, all sorts of prototyping.
Yeah.
In education, well, we're a manufacturer. We don't make we only make the sound panels. We don't make amplifiers or microphones. So we work with partners. There is an audio-visual company in Sheffield that we partner with. If anybody wants their business card, I have them with me. We have the leading sound masking specialists in Britain, unfortunately not in Sheffield, in Southampton. But you know, they've done buildings like the Gherkin, and they put 3,500 speakers into Vodafone's world headquarters in Newbury. We're partnering with those people, and if you want any of those specialities, then I can give you their business card. But Conivan's a company in Surrey that specialises in sound field for education and dealing with the hard of hearing in an educational setting. They wanted a high quality sound, so they wanted a more expensive membrane than this, but they didn't need the transformer that makes it 8 ohm or 100 volts. So we will prototype and produce products for any particular application, and then we can recommend the right people to install it for you. So if you're interested in education, I can give you Conivan's business card. If you're interested in sound masking, I can give you somebody else's. If you're interested in light and sound together, I can give you somebody else's card.
Cool. Thanks very much. Anyone got anything? Or?
I had a question about you talked about the whole range of materials that you attach these speakers to, essentially.
Yeah.
So how do you adjust for the different material properties to make sure the sound quality is?
Yeah, I mean, obviously some work better than others, and that's why we have a test rig at Salford University. It lives there.
Yeah.
So we can test all sorts of different things. And if you take a mineral fibre tile, for example, you know, part of its role in life is to absorb sound. If you take one of these metal ceiling tiles, there's wadding behind it to absorb noise. And obviously we can just take that wadding out and drop a cassette straight in. That's what this one is. But with the mineral fibre tile, we've experimented with putting a cassette on the back, so there's a small air gap between our membrane that makes the noise and the mineral fibre tile. But we've also tried completely bonding the membrane that makes the sound to the tile, and found that by bonding it completely to the tile, even though the tile was designed to absorb sound, we actually get a very good quality of music and good, you know, without frequencies dropping out and so on. So, yeah, I mean, I don't know how it's going to go with the metal ducting, because that's a new brief, that's only just happened. But certainly with glass and mineral fibre and metal and wood, the flight cases are wooden covered in vinyl, we can get a good result with all sorts of flat materials.
Cool. Thanks, Malcolm.
Thank you.
Thank you.